Welcome back to my channel. If you are new here, I just want you to know that I have series of videos for grade 6, 7, 8, and grade 9 mathematics. In this video, you're going to learn about addition and subtraction of radicals. Now, if you haven't watched my previous video about simplifying or rationalizing, you can watch, so it will be easy for you to do this lesson. Okay, now in addition and subtraction of radicals, we can only add or subtract the same radical. So when we say the same radical, they should be of the same index. So they are both square root or they are both cube root. And also the radicand should be the same. Okay, so in this case, understood there is 1 and 1 here. So 1 plus 1, that is 2. Then copy square root of 3. Okay, here, number 2, this is negative 3 times square root of 5. Why? Because 2 minus 5, that is equal to negative 3. And then copy square root of 5. Now, here in this case, look at this one. What I'm going to do is I am going to rewrite 18 and 50. So 18, wherein I need to find perfect square within this. So I can rewrite that as 9 times 2. So I'm just going to copy 8, then 9 times 2, that is 18. Same with 50, that is 25 times 2. And then, after that, get the square root of 9. Square root of 9 is 3. So what are you going to do is to multiply that. Bring that outside the radical sign because we had already extracted the square root of this. So that is 3. So what is left inside now is square root of 2. Okay, and then same thing, 25. Get the square root of 25, that is 5. So 6 times 5. And we have now square root of 2. So you notice here, they have the same radicand or radical now. And the radicand. So this is now 8 times 3, that is 24. And then 6 times 5, that is 30. So 30 or 24 plus 30, that is 54 times square root of 2. That's the final answer. Okay, so look at this given now. This one has a variable x. And this is 32. This is 128. So I'm going to simplify this. I'm going to think for factors of 32, wherein 1 is a perfect square, if there is, same with 128. And let's see at the end if they will have the same radical or radicand. Okay, so now 32, I'm just going to copy 2. I can rewrite 32 as 16 times 2. So that is now 2 times 16 times 2 times x squared. So 32 is 16 times 2. Then minus 5 and 128, I can rewrite that as 64 times 2. So that is square root of 64 times 2. Now, I can get the square root of those who are perfect square inside. I can bring them outside the radical sign. This is 4 square root of 16 and square root of x squared is x. So I have 4x times 2, that is 8x. Should be outside the radical sign. And what is left inside is only square root of 2. So 8x square root of 2. Now, same thing here. For square root of 64, that is 8. And the square root of x squared is x. So therefore, I have 8x times negative 5, that is negative 40x. And what is inside? Also, inside the radical sign is square root of 2. So now, I have the same radicand here. So square root of 2 and square root of 2. Therefore, I can simply subtract 8x minus 40x, that is equal to negative 32x, and copy square root of 2. That's the final answer for this item. Okay, now, look at number 5. I have 8 square root of 7 minus square root of 5 plus 10 square root of 5. So in this case, I cannot add these two because they are not of the same radical, or the radicand here is different. So what I can add only is this negative 5, square root of 5, and 10 times square root of 5. So understood there is 1 here. So what I'm going to do is just copy 8 times square root of 7. You're just going to copy that. And this is plus, because negative 1 plus 10, that is equal to 9. Then copy square root of 5, the same radicand. So this is now the final answer. They are not of the same radical here, or radicand, 7 and 5. So we cannot add them. Or you cannot, you cannot add them. You are just going to copy them. We cannot add also the 8 and the 9 because they are together. Okay, so that's how you're going to add and subtract radicals. That's all for this video, and thank you for watching. See you in the next one. Bye. Please don't forget to subscribe to my